Good morning, everyone. So today we'll discuss about paleobiogeography. Now, physical geography means the distribution of land and sea, the distribution of uh, continental landmass with the aquatic water bodies or the atmosphere, that is the air, and thereby distribution of different land areas, different heights, different geomorphic features, different climatic condition throughout the entire Earth. Now, in biogeography, how these surfacial conditions of Earth they are they are uh, controlling or how they affect the distribution of different animals and plants throughout the entire Earth, that is studied under biogeography. Paleobiogeography is comes, that means along with biogeography another prefix added, that is paleo. Then we are concerning about the ancient organisms geographic distributions. So the whenever along with biogeography paleo is added as a prefix, then we are concerning about the ancient fossil. Biogeography means the geographic distribution of plants and elements, that means geographic distributions of organisms throughout the entire earth in ancient time, that means the geographic distribution of fossils. Now in paleobiogeography, what we study, that is the how those ancient organisms who lives in the past time, how they evolve simultaneously with the earth and also co-evolve. That means we all know that right through the origin of organisms and right through the formations of earth, they undergo different changes. Earth formed, earth initial earth was very toxic, initial earth was very mobile, there's the initial earth was very hot, lots of meteoric bombardment are there. So with time, Earth gradually cools down. The outer skin of the Earth gradually become less mobile. So Earth becomes more stable to sustain the organic bodies. At the same time, the different Earth biotas they also undergo different changes, starting from the initial simple life, unicellular life, to different complex forms, hard part bearing forms. So they also undergo different changes, and both these are mutually related. And in paleogeography, whenever we deals with the fossils distribution, we basically try to correlate how the changing earth affect these distributions of organisms through time. That is why we use the term how they evolve and co-evolve. So individually they also evolve, along with the changing earth, organisms also try to cope up with this changing earth conditions. So that is why they co-evolve. Now, whenever we try to see the present day distributions of certain organisms, we found mostly they are showing disjunct distribution. That means they are isolated from one another. They are distantly separated, distantly spaced from one another. There is no continuous distribution. If we see the example of the similar kinds of birds like ostrich, emu, cassowary, kiwi, rhea, moa. Moa is now extinct, although they are almost similar kinds of birds. If we see their distribution throughout the earth, We can see that rhea is mostly distributed in the southern Americas. Ostrich is distributed in the southern Africas, and Epiroinis is distributed in Madagascar continents, whereas emu is here in Australia, kiwi is in the New Zealand. So you can see that they are distributed, although they look similar, in different continental landmass, and they are distinctly separated by the vast seas between them. So there is very less amount of chance that these organisms can move from one continent to another, and because they cannot move um, from one continent to another, so thereby they show isolated or separated distributions in different continents. Now, whenever this type of present day distributions of organisms are found, we try to depict some kinds of patterns. Say, for example, if we look at the distributions of Homo sapiens, that is the humans, we see that Homo sapiens are distributions in throughout all the continental areas of Earth. That means they show a global distributions. But if we see the distribution of kangaroo, that is a very renowned or famous animal found in Australia and Tasmania. So kangaroo is only restricted to the Australian continental landmass. It is nowhere found in any place of the earth. So these kinds of patterns we try to observe, and in defining these kinds of patterns, we see that the most highest diversity of organisms is found near the tropical areas. And as we move from the tropical areas towards the polar areas, we see that the diversity, that means the types of organisms, are decreases towards poles. That means with increasing latitudes, the diversity gradually decreases. In ecological terminology, this is called latitudinal diversity gradient. Now, whenever present day scientists, present day paleontologist, or present day zoologist or botanist, they found this kind of in the present day oceans or in the present day lands. So peoples dealing with the ancient organisms, that means peoples dealing with fossils, they also try to find if there are some kinds of patterns occur in the ancient times. That means whether the fossils distributions in ancient times show these kinds of latitudinal gradient or any kind of factors affecting their distribution. Now, knowledge of fossils reveals that the geographic distribution in ancient time is different what it is seen today. So people becomes puzzled that why, or and they try to find why this differentiation in distributions are there when people try to study the ancient organisms. That is, they are not matching, and the ancient organism distributions are not matching the present day distributions of organisms. So there is some differences are there. So people try to solve it out. People try to find out the answer why this discrepancy is there, and in answering this discrepancy of geographical distribution, there are two school of peoples who answer these different geographic distributions of ancient organisms in two ways. The first group is the ecological biogeographer, That means those peoples who deals with biogeographic distributions in terms of ecology. That means the peoples, they try to explain the present day distributions of organisms in terms of the modern climatic and ecological factors. So they are solely restricted in the present time, and they are saying that it is only the present day land ocean distributions, present day climatic conditions, present day geological processes, they are responsible solely for the distribution of present day organisms what we see today. In contrast, there is another group of people who believes that the past distributions of organisms, they basically giving you the present day distributions of organisms. So what we see about the distributions of organisms in the present day, that is not happened due to the present day ecological conditions. It occurs in ancient past. The organism distributed, that means their ancestry, their forefathers, they distributed in the past due to some reasons, and from that, throughout generation, these distributions rotate. So this group of biogeographers, they believe in some historical perspective. So that is why they are known as historical biogeographers. Now, these kinds of biogeographic studies are going on from the starting of 19th century. One of the pioneer worker who first uh, divided the entire earth into several biogeographic regions depending on the distribution of plants is the Swiss botanist Augustin de Candolle. He divided the world into 20 biogeographic regions in 1820. Later, in 1858, a British ornithologist, that means a British scientist who deals with birds, Philip Sclater, proposed a classification of land faunas into uh, 6 familiar regions, that is called realms. What are the realms? The entire North America, Canada is named as Nearctic. The South America is known as Neotropical. The South African portion is known as Ethiopian. North Africa, Russia, China, this portion is known as Palearctic. Uh, Southeastern Asia, including India, this is known as Oriental, and the Australia, New Zealand, this portion known as Australian. So these 6 biogeographic provinces or biogeographic realms are identified by the British ornithologist Philip Sclater. Now, here you can see another term, holarctic, that is basically clubbing these two terms, Nearctic and Palearctic, together they are called holarctic. So, Philip Sclater divided the entire Earth depending on the present day distributions of land faunas in the entire Earth, and he divided the entire Earth into 6 biogeographic realms. Later, another famous scientist, Alfred Wallace, we are very much familiar with this name. He is the pioneer co-worker of Charles Darwin. He, in his paper, The Geographical Distributions of Animals in 1876, Wallace established biogeography and he incorporated all the uh, scientific views of um, Philip Sclater and formalized many of the ideas of biogeography that persist today. So he basically also uh, believes in these six biogeographic realms along with some modifications, and those modifications of Wallace, which is proposed in 1876, that is till date persist. One famous example is that if you look at the distributions of organisms in this portion, that is the Indonesia, Burma, in this portion, the organism distribution, and the Australian portion, that is the Papua New Guinea, Java, Sumatra, in these regions, Wallace noticed that this Indonesian fauna, although they occur very close to each other, almost same latitudinal condition also, Wallace observed that this Indonesian fauna is broadly influenced by the South Asian fauna. So this is mainly dominated by the South Asian fauna. Whereas Papua New Guinea, the fauna of Papua New Guinea, that is island, that is dominated by the Australian marsupials. Marsupials is a kind of organisms. Uh, So he found there is a distinct difference between the organisms distributions in very two closely related continental landmass. One is uh, dominated, one is mainly occurred, mainly consists of the oriental faunas, and one mainly consists the Australian faunas. So there he plot a boundary which according to his name is nowadays known as Wallace line. And remarkably, these distinctions noticed by Alfred Wallace is still persist. So many these kinds of differences. Another transition is observed in the North America and South America. So there is also a distinct difference between the North American landmass and the South American landmass. So these kinds of uh, modifications of Sclater's land fauna's distributions uh, later also accepted by Alfred Wallace, and with some modifications it is still persist nowadays, but all these are of, mind it, all these are of recent day organisms. Now whenever people are found these kinds of organisms, different types of organisms in different groups occurring in different continents, so people look whether these kinds of organisms grouping, organisms differentiation occurs in the fossil record or not. William Oliver, one of the pioneer worker, he was studying on the one type of coral, that is rugose coral, and he described the distributions of rugose corals in the Devonian of North America. During the distributions of describing the distributions of rugose corals, he found also these kinds of disjunct distributions of corals. So that means these kinds of disjunct distributions of organisms are also occurred in the ancient times. Now, paleoecologists, they found some difficulties uh, distinguished distinguishing between more or less similar contemporaneous fossils of two areas having different compositions. and often the environment of those areas are also similar. So being a paleontologist, when you are only able to observe the fossil present in the rock record, many times it was observed that fossils of two areas have different compositions. Although the ecological conditions, that means the temperature, pressure, salinity, water depth, all these ecological compositions might be similar in those two areas. So the question comes, who governed, or who are who are responsible, who is responsible for this different composition of faunas in ancient times? Because the ecological conditions are same, that means they are occurring more or less in the same latitudinal conditions, latitudinal position of the earth. So in this same ecological condition, why there are two different composition of faunas or composition of floras? So people try to find the culprit who is responsible for this difference. Now, if differences between fossil biotas cannot be explained by differences in environment, that is means differences in ecological conditions, then paleontologists conclude that they were produced by some kind of barriers. That means there must be some kinds of restriction by which the organisms between those two areas cannot meet with each other, and thereby they are completely isolated from one another. So if they are able to mix with one another, then they show some evidences of that mixing. Then there may be some similarity between those faunas. But if they are not able to meet with each other, so there must be some kinds of barrier. That is why they cannot meet with each other, and that is the reason for their disjunct or isolated occurrence throughout the earth. Now, what are the barriers? The barriers must be natural. So for an aquatic or for an organism living in an ocean, land is a barrier because the aquatic organism cannot move from one place to another throughout the land. Similarly, for land organisms, oceans or aquatic bodies may be a barrier. A large mountain chain like our Himalayas, that can be a barrier. So it is almost impossible for us or for most of the peoples to cross the entire Himalayan range across and go to Tibet or go to China. It is almost impossible. So these kinds of natural things, these kinds of natural environments, they became barrier to an organism, because for moving over through these barriers, the ecological conditions in which an organism is sustained, an organism is favored, that ecological conditions is changed during passing through these barriers. So organisms are not able readily to cope up with these changing ecological conditions, and that is why organisms becomes isolated by these kinds of barriers. Now, if there are barriers, lots of barriers, then how organisms are distributed throughout the entire earth? The foundations of the distributions of organisms, that is the biogeography, were laid in the 19th century when it was thought that the positions was continents and oceans are fixed. That means it is far before than the origin of plate tectonics theory, and it is even before the concept of continental drift theory. So early in the 19th century, when there was no proposal of continental drift theory even, biogeographers believe that the positions of continents and oceans are fixed through time. So each group of plants and animals, they are considered that they have first appeared in a location in the entire earth, and from that location they gradually move from one place to another. That is called dispersal of organisms. And whenever organisms appeared in one place and from that they are moving to another place by physical walking or running or crawling or by flying, so thereby they are going through newer areas and thereby extending their range, extending their geographic distribution. Now in Bible also, or in many ancient literatures, there is a famous story which is called, there is a girl who is named as Noah, and one day in her dream God appeared and told Noah that in the coming few days there will be a severe flood, and in this flood the entire earth is flooded with water, and all the living and non-living things will be destroyed. So God told Noah to take all her necessary things along with the organisms around him to a vessel, to a large ship, and shut the doors of this vessel, of this ship. So like this, Noah, the little girl, followed the God's words. He take, she take all its necessary, all the necessary things along with all the organisms. Uh, he formed a large ship, take all the organisms along with her and her necessary things to the ship and shut the all the openings of the ship. And in few days, a large flood came. It flooded all the earth, and after a few months, when the flood recedes, then organisms uh, or the ship is found rest over the Mount Ararat, which is situated nowadays in Turkey, and all the doors, windows are of the ship now opened, and from that organisms came out and spread throughout the entire earth. So this is a story found in the religious books, and this ship is known as Noah's Ark. So from that uh, religious idea, the ancient peoples mainly, who are very much religious, and they are mainly guided by the religious older peoples, uh, they believe this kind of theory, and it taught us, or it told us, that all the organisms, they appeared in one place, and from that they gradually distributed throughout the entire earth. So it is also known as the center of origin theory. That means all the organisms appeared in Mount Ararat, and from that center point, organisms nowadays distributed throughout the entire earth. Now, in this Noah's Ark theory, organisms are directly responsible for dispersal. That means organisms are directly moving from one place to another by himself or herself. But not always organisms have to move themselves, although they are distributed in different places. There comes another uh, theory supporting this dispersal event. It tells us that it was found that in many ancient many past books we found that there is a vast amounts of wars between the uh, peoples who make their business through the seas, and they are attacked by the bad peoples. They did war, and during this war some ships are completely destroyed. All the living beings, all the humans of that ship are killed. All the things they are taken by the bad peoples, and the ship remained floating with all its with all the dead bodies. So the ship containing all the dead bodies is now floating over the oceans, and with the ocean waves and tidal effects, it as it has no control, it can move into any directions along with the dead bodies. Now, by day after day floating this dead body containing ship, it will come to any coastal areas throughout the entire earth. So those dead bodies are now found in an areas where the chance of getting those dead bodies is almost zero. But we get those dead bodies, or we get those organisms along with the ship. So it may be possible that the organisms, they are not dispersed themselves from one area to another, but after their death, the ship carried them. That means the continental landmass in which they occur, they are moving from one place to another. That means this theory appeared after the proposal of continental drift theory. That means continents are not static, continents are moving from one place to another. So during its journey of continents carried all the living and dead bodies along with itself. That means living organisms along with all the fossils along with itself, and distributed in different positions of the earth. So thereby, nowadays, whenever we see the distributions of those ancient organisms, we may found disjunct distributions. So the dispersal theory said organisms itself can move from one place to another, and thereby they show uh, different locations where they occur, and with time these locations there appeared some kind of barrier, so that they can never meet further. So thereby they show some kinds of disjunct distribution. Another way of dispersal is that continents, they move along with living and dead bodies, and after some time they occur in different geographic positions with its uh, all the beings, that means all the living organisms along with the fossils, and thereby also they can show a disjunct or isolated distributions of organisms. Now, one famous example is the Paleozoic, upper Paleozoic distributions of some plants and animals. Glossopteris, Mesosaur. Glossopteris is a leaf. Mesosaur, Listosaur, these are reptiles. If you see the distributions of these organisms, these plants and animals, they are found in almost all the landmass, all these landmass, that is in India, in Madagascar, in South Africa, in South America, in Antarctica, in Australia. And if you see the distributions of these continental landmass areas in the present day, you can see that they are vastly separated by huge oceans. So these reptiles, which mainly occurs in the river banks, or these continental terrestrial plant, they cannot move through these huge oceans. So no questions about dispersal of those organisms in uh, this type of positions of continental landmass. So how will they move? It was thought that during the upper Paleozoic time, all these landmasses are close together. That is South America, Africa, India, Antarctica, Australia. They are very much close together, and there was a supercontinent consisting of these land masses in that time, that is called Gondwana Land. So together with South America, Africa, India, Antarctica, Australia, Gondwana Land was there during the Upper Paleozoic times. Now, as these land masses are connected with each other, so there will be no barrier, and these continental animals or continental plants, they can be easily dispersed throughout this continental landmass. So that is why these are found throughout this supercontinent Gondwana land, which later drifted in different positions in the earth. That means these continental landmass, after the upper Paleozoic times, during the Mesozoic and Cenozoic times, they moved from this place, and nowadays they positioned in this place. So this continental landmass is acting like a funeral ship, which carries all the dead bodies of the upper Paleozoic time. That means which carries all the fossils along with itself of the upper Paleozoic time, and they are now showing these kinds of isolated distributions throughout the entire earth, having different latitudinal conditions, having different ecological conditions. So during upper Paleozoic time, these landmasses show almost same kinds of ecological conditions. That is why same kinds of uh, terrestrial plants and reptiles are found in almost all these continents. Later, these continental landmass are drifted apart from one another, and they show these kinds of disjunct distributions, but it carries all its contents, all its fossil occurrences along with it. So although they are now show these kinds of disjunct distributions in during the uh, occurrence of, or during the living conditions of these kinds of organisms in the earth, these these continental landmass are close enough to each other so that they can disperse from one continent to another continent. Now, biogeographers who believe in this dispersal theory, that means center of origin theory, require some special mechanism to explain the occurrence of a taxon in two or more areas which are now separated from one another. For them, each newly evolved species spreads from a center as it competes with less and less well adapted organisms. So these kinds of biogeographers who believes in the dispersal theory, that means center of origin theory, they always believe that all the organisms, they occurred or they first appeared in one place of the earth, and from that they were distributed. So these kinds of theory need some special mechanisms by which these kinds of distributions is can be explained. So if people believe in the uh, theory of Noah's Ark, then uh, all kinds of organisms appeared in Mount Ararat, which is situated nowadays in Turkey. So all organisms of upper Paleozoic time, like those of Glossopteris, Listosaurus, they must be also appeared in Mount Ararat, and from that they were now distributed throughout the entire earth. So these kinds of believing of dispersal of organisms from a center point is mostly unscientific and is mostly some kind of storytelling thing. Around 1805, Alexander Humboldt, he proposed that continents were once connected by land bridges and that others had drifted apart. So Humboldt proposed that how those continental organisms move from one continent to another. So there must be a bridge, because nowadays we can see that those continents, if you look at the continental landmass between Australia and Antarctica, they are distinctly separated by the huge oceans, Antarctic Ocean. So how organisms move from Australia to Antarctica, or the reverse, Antarctica to Australia? Humboldt believed that there must be some kinds of bridges through which organisms can move from one place to another. And this kinds of belief was far before again the proposal of continental drift theory. So till date, the continental drift theory was not also there. So organisms, again, he is a believer of dispersal theory, and he believes that organisms moves from one place to another place through these kinds of continental land bridges, or continental or it may be a oceanic strait, ocean bridge. So these are known as corridors by which uh, the organisms can move from one place to another. Now, sometimes the route or these corridors are not a freeway. That means all the organisms living in one place, they cannot move through this bridge in a freeway. So there must be some kind of restrictions by which organisms are filtered. So some organisms can move past, others cannot. These kinds of bridge, according to Simpson, they are known as filter bridge, because it was found that many organisms still remained in its own native place. The famous example of the woolly rhinos and pigs, which never migrated to North America from the South America. So there was a land bridge that is known as Isthmus of Panama between North America and South America, and it was thought, or it was believed, that the organisms of North America and South America, they are moving throughout this land bridge, that is Isthmus of Panama. But it was found that some organisms like the woolly rhinos, they never migrated to North America. That means they are filtered and they retained their original native place. So these kinds of corridors in which there was a filter, in which does not act as a freeway between two continental landmass, they are known as filter bridge. So there was a corridor, but that is not a freeway. Some islands, they have no native organisms, and there are some islands that have no organisms, and it was found that during some storm, during some abnormal activity, during some high flood, some organisms are swept away from another place and taken to that island. So now that island comprises of some organisms which are not native to that place. But with time, those organisms are completely separated from its original pool. So thereby they show a different evolutionary pathway which is only restricted in those island landmasses, and they becomes very much uh, particular and restricted to their part, so that they becomes endemic. That means they were nowhere found in the entire world. So there was no organism in the island landmass. They came through some abnormal event, through some flood or through some cyclone, through some storms to the landmass. Now they are bounded by the natural barriers to live in that island landmass, and thereby living in that new conditions, that those organisms try to cope up with this new environment, try to cope up with this islandic habitat situation. So they show some new morphological changes, morphological adaptations, and thereby they follow a new evolutionary path which may be different with the original pool from where these island organisms came. So these island organisms now becomes completely restricted. That means they are completely endemic to this island landmass. Now, such a low probability of transport, you can see that storms, these kinds of large storms, these kinds of large floods are not occurring every day in Earth. So such a low probability of transport of organisms from one place to another is called sweepstakes route by the famous scientist Simpson. So the pathway between two land areas or between two areas can be of three types. One is corridor, which is a freeway. Second is filter bridge. So there is some kind of filter by which organisms moving from one place to another. Not all organisms are able to move within this pathway. And the third one is the occasional abnormal movement of organism through some natural events. That is sweepstakes route. But through these processes, organisms can move from one place to another. Now, the barriers to dispersal, the continental landmass, as I already told you, for ocean organisms, for aquatic organisms, the land areas may be a barriers. Oppositely, for land organisms, oceans or large aquatic bodies, large water bodies may be a barrier. For shallow ocean organisms, water depth, higher water depth may be a barrier. Temperature may be a barrier, and also mountain ranges may be a barrier, deserts may be a barrier. So there are lots of barriers are there in Earth. That means these barriers indicating that a different ecological setup which an organism have to pass during its movement, and this might not be favorable for that organisms. So that becomes a barrier to that organisms to move from one place to another. Now, the dispersal theory have many drawbacks. There is no rigorous method of deciding where a taxon originated and when and in what direction dispersal had occurred. If you believe in the Noah's Ark theory, then all organisms appeared in Mount Ararat. So when people try to found The evidences of this center of origin in Mount Ararat in Turkey, they did not find any evidences. They did not the appearance. They did not find the evidence of occurrence of the Noah's Ark over the Mount Ararat, and they did not find also the evidence that in which direction the dispersal will happen, whether it is in north, whether it is in south, whether it is in west or in east. So what is the direction in which the organisms move from this center of origin? So from that, it appears that this dispersalist theory is mostly a storytelling and unscientific. It cannot be testable. It cannot be tested. So people try to go away from this dispersal theory. When people are going away to the dispersal theory and it becomes almost untestable, unscientific, then another theory came into the scenario, which is called Vicarian's theory of biogeographic distributions. Now, plate tectonics theory came into the uh, 1960s and 1970s. When plate tectonic theory came into the scenario, many people believe that it will revolutionize the entire uh, organic distributions throughout the entire biogeographic study. So, with the appearance of plate tectonics theory, peoples of different streams, they try to apply plate tectonics theory in their own streams. Likewise, paleontologists, they are also applying plate tectonic theory to solve many unsolved problems. Now, paleontologists who deals with the biogeographic theory and who are not satisfied with the dispersal theory of biogeographic distributions, they try to replot the fossil distributions in the newly developed plate tectonic earth map. Now, one group of scientists looked the biogeographic distributions of organisms in a new angle. That is, they try to find whether the plate tectonics fit the predictions of organisms in a proper way. This school of thought, who believes in this kind of biogeographic distributions with the help of plate tectonics, they are known as Vicarian's biogeographer. They argued that Vicarian's method changed biogeography from the absolutely storytelling, untestable approach of dispersalist theory to something which can be tested, which is testable. Now, the idea of Vicarian's theory is first proposed by the Venezuelan botanist Leon Croziat. Croziat spent decades or a lot of time in documenting geographic ranges of many different species of plants and animals. Now, during this study of documenting distributions of plant and animals, Croziat argued that biogeographic distributions of plants and animals, they are initially large. So they are not originating in a central point, or they are not restricted to a central place, from that they are migrated. No, in Crozier's point of view, the initial occurrence of organisms or the initial positions of organisms in the entire earth is occupying a large area, and that large area, that large geographic area occupying those plants and animals, they later fragmented and formed smaller areas, smaller pieces of earth uh, surface containing those plants and animals. Now, in each of these uh, earth pieces, a vicar species, that is the representative of those ancient plants and animals, they are they are in those smaller pieces of earth, plates. So from those vicar species, the organisms evolve and flourish. Now, what is vicar? Vicar is, in Latin, is a representative or replacement of some replacement of Christ. He is also a religious people who uh, is the uh, clergy or representative of Jesus Christ. So the newly fragmented pieces of earth land surfaces, they already have some kinds of those representative of the previously uniform land areas of the earth. From those vicar species, now those distinctly separated land surfaces, they individually evolved and formed newer and newer organisms. So organisms which previously occurred together due to some tectonic uh, disturbance, they are forced to be separated and occur in different ecological setup, in different latitudinal, longitudinal setup. That is the fundamental theory of the Vicariance biogeography. There is also some limitations in the Vicariance theory. Although Vicariance theory is much more testable, much more scientific, but all the distributions of organisms throughout the entire time span of Earth, they cannot be uh, justified by the Vicariance theory. Say, for example, the very recent history in the late Cenozoic times, the distribution of vertebrates, land vertebrates particularly, they cannot be explained by the slow process of continental fragmentation through plate tectonics, because we all know plate tectonic process is very slow process. So within, if at all the organisms are static, organisms remain in the positions where they are, and they does not move from one place to another. It is only the tectonic plates who are responsible for moving the organisms from one Earth's latitude longitudinal positions to another latitudinal longitudinal positions. Then that will take a huge amount of time. And in the recent histories, that is in the less Cenozoic distributions of vertebrates, when people try to document their distributions, they found a much more faster distributions, a much more faster event of vertebrate distributions occurred, which cannot match with the pace of the continental fragmentation by plate tectonics. So that requires a dispersalist explanation, that is, organisms also move from one place to another. So it was thought, or it was proposed nowadays, that although vicarious biogeography is the most scientific method, scientific way of uh, defining the distributions of Earth's organisms through time in different areas, but vicarious biogeography cannot completely cannot completely explain the distributions of all the organisms through time. Sometimes it cannot match the pace of organisms distribution throughout the entire earth. So vicarious biogeography theory cannot completely nullify the dispersal theory, although dispersal theory is mostly storytelling, mostly untestable. So it was now thought that along with the vicarious vicarious biogeographic theory, dispersal of organisms also happened. So both these processes of uh, distributions of organisms are going side by side, and that will depict the distributions of present day organisms throughout the entire earth, and also in the uh, ancient world, also the distributions of fossils. So in conclusion, it can be said that paleobiogeographic evidences not only suggest that continents had drifted apart, that means plate tectonics is occurring there, but even open the door to our understanding that how these continents are put together, and how, apart from the continental movement, organisms take a vital role by themselves also to move from one place to another place. So whenever, being a paleontologist, we are going to study the paleobiogeographic distribution, we must be very aware about these two kinds of models. We must take into consideration about the plate tectonics, as well as the ability of dispersal, the ability of moving of organisms from one place to another. Thank you. These are the reference books by which you can study this part. Thank you.